So thank you everyone for being here. So yeah, let's start talking a little bit about reactivity. But before, who the heck am I? So I'm a developer relations engineer. I work at a place called Crab Nebula. More on that later. People are very involved in the Tauri framework. If you haven't heard about Tauri, you will in a second. The second part is I'm also a member of the SolidJS developer experience team, which means I'm maybe a little bit biased about the things I'm going to talk about, but just a little bit. And I'm also a Google developer expert for web technologies, but yeah. And because naming things are very hard, I made some shortcuts. I'm in every one of these social media. You just put atila.io and pick whatever you want. And if you message me, I'm going to reply. I'm always up for a chat. And yeah, that's who am I. So because of my work at Crab Nebula, I need to test a bunch of frameworks. And because of what I do at SolidJS, I also need to have a look at the APIs and stuff like that and think about rendering performance and so on. So I am very convinced fine-grained reactivity is a great thing. And so, yeah, so basically you just heard it. So someone said fine-grained reactivity is going to help you ship better apps. And the first thing, before going refactoring all your stuff, the first thing you need to do is ask one question. Why? Like, don't take any word for granted. So does anybody know like any reason why fine-grained reactivity could help you ship better apps? Any like single word? Anybody want to shout something? Yeah, performance. Thanks, Stages. I set it up and he helped me. So the thing is, a lot of people talk about performance. A lot of people, when we talk about fine-grained reactivity, you immediately jump into performance, and that's a little bit, hi, Nathaniel, cool, nice to see you here. So the nice thing is, we talk a lot about performance when it comes to fine-grained reactivity, but to me, that's a very nice side effect of fine-grained reactivity when dealing with apps. The real reason to me is on the mental model. And to that, we need to very briefly talk about different ways of handling data in your apps, or data, I guess. But anyways, you have the pull way, so you can pull the data. You have the push way, which the provider is going to push data into your app. And you have another method, which would be push and pull. So let's talk a little bit about each one of them. First with the pull. So essentially, you have the provider of the data and the consumer of the data, which is the data part and this part in green, and the component that's going to take it. So the component needs to, every time it needs to fetch for updates any single time. So if they're re-rendering or something like that, they go, oh, do you have updates? No. Do you have updates? No. Do you have updates? Yeah, I do actually, take it. So this is, as you can imagine, it's a pretty inefficient method, because every now and then you're basically doing some manual pull, I would say, and it does some consequence in terms of the data is not able to let your engine know it's updating. So basically, you need to do a lot of extra work to accommodate this. The second way is the push version, where a data becomes available as soon as the provider has it. So the provider just shoves it into your component, and that can cause some other issues in terms of, like, if you heard about back pressure, where at some point the data has no way of knowing if your app is ready to take the update. So it just keeps sending updates one after another. So that's, you probably have heard about words like debouncing or throttling and stuff like that to handle this kind of back pressure. So it's a way of more imperative handling this. But when it comes to observers and this kind of stuff, you have no way of handling that. So this can cause some issues. This can cause either your data to your component side to just give up receiving the updates, and then you happen to have stale data somewhere, and state tearing because one component was able to update, the other wasn't. And you might have other more serious issues if you don't care about, if you don't look for it, which is potentially even crashing your app or something like that. And then you have the push and pull method, which the data signals to your, see what I did there? I updated. And then everybody that depends on the data gets the notification that it got updated and say, okay, please send me. And then you can get it. So this kind of prevents the back pressure issue. And in the same way, in the same thing, it also prevents you for needing to check everything and make sure that your app is up to date on the pull version. You need to basically re-render the whole thing. You need to destroy the current state and build it up again, because you don't really know which components are using which pieces of the data. So to make this whole analogy a little bit more clear, if you haven't figured out, pull state is what use state does, and like, for example, use state in React, I would say. So essentially all the every time you have some virtual DOM or some block DOM or this kind of other stuff, when you're not handling with any kind of subscription model, you have a pull version. Push data would be more like the observer pattern, more of like what, both of them are observer patterns, the push and pull, but it's more on the observer side, like RxJS or things like that. And then push and pull is what we do with signals. So I use create signal there because I'm SolidJS guy. There's some Svelte people here. They would use runes and this kind of stuff. So Vue people would use refs, but essentially they're the same pattern. So this means if you're more of a React developer, you're used to like having the component smushing together rendering and data. With signals, you kind of split them apart again. So your data is responsible for itself, and you don't re-render the stuff over and over again. That's the mental model that shifts on that, which can lead you to have more performant apps, because mutating stuff is way faster than tearing the whole thing apart and starting again, as you might imagine. So just a little history look back. When SolidJS came out, the creator of SolidJS said, okay, signals are a pretty great thing. Like some other frameworks try to do it, but they lack a little bit of the X here and there, but I really think we should have a framework built around signals for that mental model. And there were already some frameworks experimenting with that. Vue even had their own implementation of signals at the point, but the rendering model was a little bit more coarse, was not that fine. So if you fall out of the reactivity, it would do a whole update to make things more resilient. And fast forward a few years, what happened is that all the other frameworks realized, oh, that actually saves us a lot of hassle in terms of explaining how our rendering method works, in terms of helping our users actually ship better apps and more performant from the get-go, because that's what frameworks are all about. Like, frameworks are supposed to make your life easier in shipping with a higher quality standard than if you do it by yourself. So to summarize, what happened is that somebody said, yeah, I can use Memo whenever I want, and said, yeah, I actually have signals. And you see where this is going, essentially. And to point out like the reactivity part of Solid, what we do is, if you look at this from a reactive, there's a lot of comparisons to React because it's the most like common framework. Who here is a React developer or worked with React more? Cool. So yeah, I'm not that wrong. Awesome. So if you look on the first glance, and if you squint your eyes a little bit, it actually looks like a React component, right? But we have this create signal there, and fundamentally, though you're building your component in the very same way because you're also using a certain flavor of JSX, things behave differently. So like if we render this button in a screen and we click on this button, what would happen in a React thing is that the whole button goes away and then it comes back with the new state. With Solid or with fine-grained reactivity, what happens is once you click on it, there's one piece that updates actually, which is just that little function call. So your DOM node doesn't go anywhere, it just gets mutated. It updates the DOM node only on the value side, only the text node, which leads to the whole like thing that, oh my God, signals are so performant, yada, yada, I'm gonna use that to make my apps faster. That's the thing. So you don't actually need to prevent re-renderings because they don't exist. So yeah, never using Memo again, right? That's the point. Well, there are situations to use Memo. Memo is not like a bad pattern. The problem is when you use Memo to fix engineering problem, where Memo is a whole different solution, is to prevent computation that you don't want to happen again. So I have this little very contrived example where if you have, like in this case, we have in the super count, we have what we call a derived signal, which is a signal that is built from a value of a previous signal. And this is basically having a multiplier there. But the way I'm doing, which some of you might be cringing already because it's not a great way, because I'm recalculating the multiplier every single time I call that function. So you probably already noticed I don't want to do that, because that's gonna mean that every time I call this function, I'm gonna change the actual value. So this is a very contrived example, but it's supposed to exemplify why would you use a memo. So let's have a look at this little. Where's my mouse? Yeah. So so we have the docs, and so I just put the same component I had in the screen. Like I changed a little bit just to make it a little bit easier to read. Let's zoom in a little bit, because you don't need to care about the return type on the JSX and whatever. What you need to do, what I want you to look at, is that I have the super count being rendered here in a bullet point, and I have my actual count. So for the same value of the count, I have multiple different ones. And every time I change the count, I need to call the function again, because super count is actually subscribed to the value of count. So when count changes, I need to recalculate super count. And when I'm recalculating super count, I actually have the multiplier being calculated again. So this would be a decent way to having a memo here, because if I do the memo, it means that I'm going to recalculate the multiplier only once every time the count changes, because if count didn't change, I don't need to run anything again. So why I say this is a contrived example, because there's actually a better, a different solution that I could do, which is a variable. Because this doesn't run again. If I just store this as a reference in a variable, I'm not going to calculate any time anymore. So that's why I said this is a contrived example. In a real world, you would have something very much more complex in a derived state that would require a memo, but that's the actual use case for a memo. So if you have something that's heavy for you to compute and you want to make sure it's only going to run once, that's why you use a memo. It's not to prevent like small re-renderings or stuff like that. And yeah, so that's the whole point. But yeah, that's all nice, this pseudocode. Every time it's nicer, it makes things look easy, and then you go try it out. But your state doesn't look like a Boolean all the time, right? It's not like a simple count. You actually have complex types. So let's take these complex types and shove it in a signal like this. So you have something like a list of users, and you have accumulator to count the number of users you have, and so on. So how do we do that? How do we fine-grain reactivity that? Ideally, you would want something like this, right? So for every new thing, you get a new signal, and then you can update one by one. But can you imagine writing that? So that's why we have stores. So stores are basically create an object proxy and do that under the hood for you. So what we have here now is actually all the values inside this store are their own signal. So you can actually do everything one by one. And if you update only one, you're going to update only that little piece that changes. You don't recreate the whole object as you would with a signal. So yeah, and that's the signature. And yeah, but then, okay, how do you go with deep nesting in this case? If we have something like an array up right there inside an object or something like that, how do you update that? Because then you need to, how you do with that? So for that, we have something called produce, which is a helper that's part of the solid core. And then you can have this mutate syntax, and that's going to handle the whole fine-grain reactivity update. So you can just cascade down everything you want. So in this case, it will just update granularly what you want. And that's also good. But what about the other way around? What if I have an API that's going to give me the whole object and I don't really control the object, and then I need to tear the whole thing up again? So yeah, you could tear up the whole thing again and let the whole value update every single place. But let's say, for example, I have this weird to-do app that I actually want to look at my past to-dos, like grocery store, and want to buy the same stuff I bought last week for some reason. So for that, we have something called reconcile. What reconcile is doing is going to have a shallow, it's going to do a shallow comparison to each one of the keys inside your complex object or type, like object or array, and it's going to shallow merge every single one of them. So that's going to guarantee you in this one-liner that if you have like a big update and you really don't know what changed or not, you call reconcile and Solid's going to figure it out for you. So to recap, fine-grained reactivity is about surgical changes instead of re-rendering. So that's the whole point that leads up to us skipping the whole beat and saying, oh, that's great performance. But actually, there's a whole mental model where you're only going to change what you wanted to change. You're only going to re-render what actually changed. You're not going to terraform your whole app just because you changed the Boolean. But that's for re-rendering UIs. So, but everybody now has a cool like isomorphic framework. They're all full stack developers. We're all going like blurring the lines between backend and frontend. And that's why Solid built a meta framework called Solid Start. And it's now in RC, which means in a few weeks it's going to be considered stable. What we're doing now is like testing, doing small bug fixes. We're having conversations like what should be the prefix for environment variables or stuff like that. The APIs are stable enough. But what the heck does a release candidate actually means? So just to make sure we all have the same understanding, when shipping an app, you have the alpha release, which means you're still working on the APIs, you're finding out use case, you're finding out what your users actually need, making sure everything works. So this is like very unstable territory. You go there as a tester, you go there as somebody that's interested to help, and you can use that. Once that's done, we go to beta, which means, okay, we found a model that we think works for our project, and we want people there can actually afford to test it and make sure it works the way we expect it does. And then we get to RC, which means we tested like thoroughly already, but we're lacking documentation, and we might have a few quirks here and there if you have a less traditional use case. And that's the stage we are right now. And then once we fix the small bug fixes, but most importantly, when we're confident we can onboard people successfully, then we go into a stable release. And talking about stability and the shape of this framework, Solid Start is actually very, very meta in terms of a proper meta framework, because Start itself is a very small package, but then it just puts together a lot of different packages, which means that we have our backend built with the same infrastructure that Nuxt has and Analog has. So this means that from the get-go, even when we were still beta, you could, for example, ship Solid Start to Nuxt hubs, for example, because we are all built with Nitro, which is an agnostic solution. Our server runtime is that, and all these other frameworks use. So this means that though Solid is a smaller community than a lot of frameworks, if you have an issue on the backend, you can actually piggyback on the other ones. So you can actually look at solutions that other frameworks are already doing, and you can use that. So we have this package called Vinci that was actually made by one of our core members that encapsulates Vite and Nitro to make sure we can split the bundle between server and client side, and we can have a proper runtime that has already been beta tested and has been in production even before we ship Solid Start. Then you have the serializer, which is a beast. Like it's something we're going to talk a bit later that's going to handle all your data modeling between the front end and the back end, serializing, like crossing the network boundary and reaching your user. This is like very complicated, and this is why we had to create this package that's tailored for Solid Start. We look at a lot of other frameworks. We took a lot from SvelteKit, for example. They have a great serializer as well. But in the end, for what we wanted to accomplish in Solid Start, we had to create our own. So another core member built this whole separated package. So any other framework that wants to use that in the end can do it. We have router, which is completely agnostic. You can bring your own router to the story. At this moment, unfortunately, the only router that has all the integrations required to have a Solid Start running is the Solid router. but Vinci allows you to very easily tweak and switch if that's the case. And then you have Solid in the very end of the thing, doing the whole UI rendering stuff. Okay, and that's all great, but that's way too technical. Let's talk about the features we have and what makes it different. The most important thing, and the thing that we went completely on removing, is request waterfalls, because that's what actually makes apps feel terrible. Because you have chain requests, and then the request number 2 can only start when request number 1 finishes and actually arrives and parses and etc. So we abolished them. It's really hard to make request waterfalls in Solid Start. Actually, in Solid Router itself. And then because we have resource fetching in parallel by default, we can have something like, this is actually a real use case app. I wanted to show you this first because you see, if you're a React developer, you're used to this whole nesting provider stuff. We have the same problem, same pains. But what I actually want to show you is this. What I want to show you is that we can wrap our whole app into a suspense. So every route navigation is by default. When you're in the client side, post-hydration, everything is soft navigation. And you can have an intermediate state between routes as easy as that. So in this case, you have the root, and inside the root, all your file system routes are in this props children. And you can have like this pending state or whatever you want, which allow you to control the preloading method, which allow you to control when resources are going to be fetched and when your routes are going to actually load. Talking about data loading, we have this thing, which is the create async, which is how you use data from a loading method in this. So you can have something like this if you don't want to show your app, if you don't want to actually show your component before the data arrives, you can have something like this, and then you make sure that Solid is only going to render that once the data arrives. Other than that, this actually is where you protect your route if you want. So we protect data, not routes, in a Solid Start app. You can also do the defer stream, like if you're doing something that's very SEO intensive and you want to make sure the data is there before anything starts rendering, you can say to Solid Start, okay, just wait. I know what I'm doing. I don't want you to be as fast as possible. I actually want you to be as consistent as possible. Talking about preloading, you can actually just export a route like this and say, okay, so I want actually Solid Start. Every time you hover my link, I want you to actually start preloading stuff. So you fire the request before I actually navigate. So that means that even though you do all this whole shebang of not rendering anything before your data arrives, chances are, by the moment your browser reaches the part about rendering that component, the data is already there anyway. And talking about protecting stuff and caching and deduplicating and performance like that, we have this helper method, which is cache. And you can define that the data loading and the data fetching is only going to happen on server side just by using a directive like this. And Vinci is going to take care of everything. It's going to make sure this never lands in your client bundle and so on. And the caching method is to deduplicate request. So you've heard about like other frameworks that changed the prototype in fetch and stuff like that. And we saw that most people didn't like that. So our solution is actually exporting a cache method. And if you pass like a string key, you're actually helping Solid Start understanding that this request has this unique key. And then every time this key tries to go out of Solid Start to fetch something, we see if there's already something in flight. And that's why we deduplicate requests, but we also deduplicate resources, which to the best of my knowledge, we're the only ones kind of doing that. So the way it happens is you have this API and you have like 3 server functions that are actually sending the same request. So this hits the cache, which means you're only going to get 1 request going out of your API and 1 request coming in. Once that happens, it reaches a serialization, the serialization part. And that serialization is actually gonna make sure is gonna make sure that the request, the resource that's being serialized is gonna be stored on this, for the lack of a better term, global store. That's gonna make sure that that resource that already exists never gets serialized twice. So even if you have different requests that's coming back with the same resource, you're serializing only once. And then we go to the RPC layer, which is the procedure call, and then we reach your user. So We also have server actions, which is essentially very, very, very similar to what the server function is. But in this case, it's a nice synthetic sugar to deal with forms and handle the form submission. So it's pretty similar to what other frameworks do, like Remix, was, I think, the first one doing it. And you can actually throw redirects, which leads to the one that I think is the most interesting feature of Solid Start, which, so here you have an action that happens only on the server. And if you're returning a redirect or throwing a redirect from a server action, so let's say you have a login feature and the user didn't fail to authenticate or something, or actually authenticated, and you're sending them to the user dashboard, what happens is the same request that is going to authenticate your stuff is actually returning the data from the next page. So in this case, my login page goes to check if my user can authenticate, and when it comes back, it's already coming back with the list that I want to show. So you return a new page with the data of the page that you want to re-render. So you're saving possibly 2 round trips, but at least possibly 3 round trips, but at least 2 by doing that, because every time you're redirecting, you're already coming out with the data. That's why we call it single flight. And then besides the single flight and returning things, you have complete control of like revalidation, reload, caching. You can the whole point is to give you nice defaults, but being completely unbiased on how you're going to use the app. So you can at any moment remove anything of our settings, or even like the whole router, as I said before. If you want to know more, we have the docs that Daniel with me and Sarah are trying to get everything up to speed to leave RC as soon as possible. So you actually could take your feedback on anything there. And if we fail to onboard you on anything, let us know. We're always on Discord and stuff like that. So quick recap. If you're doing front-end, you want to fine-grain reactivity, I recommend you Solid. For full stack, you can use Solid Start. What about native? And when I say native, I mean like any other operating system. If you want to have like an installed packaged app experience with Linux, Windows, Mac OS or iOS or Android, my recommendation, and again, I'm biased because, as I said, I work at Crab Nebula. We are the ones behind Tauri. You can mix them both and have a hybrid app. And that's actually what I do at work. So just for the ones, who's familiar with Tauri, by the way? My friends? Yeah? Awesome. Cool. So Tauri is a framework to building hybrid apps. So it uses Rust as the backend layer. So the window management, the native window part. And then it has a component that brings in the native web view from the system you're at, which means you can use any web technologies. You can use jQuery if you want. You can also use Svelte. You can use any framework you want. It's literally bring your own stuff. So at work, we actually have a web app that's a single-page application built on Solid. And inside this monorepo, we actually have something that's wrapping it into a Tauri app. And then we can have an installed experience as well. And I made a template because that's kind of what I do most of the time. So this brings you like a lot of like sensible defaults if you want to package your app. Sorry, if you want to debug it, and it's open source, it's a little package you can do. Like, I suggest you using dgit, but you can also hit the button on GitHub. And if you go through the whole like little system requirements, you have to do that for like mobile apps. I mean Android and iOS. You can actually build the 2 apps at the same time and your web app and have everything running at the same time with hot module replacement. It's pretty cool. And my template's like opinionated. You have Solid, you have Tailwind, and Tauri set up for you with some defaults for best security and performance. And that was kind of it. Thanks a lot. And you can find me on YouTube or X or anything else. Thanks.